Hello, so today I would like to show you a new feature available in public preview for the Foundry hosted agent platform, the activity protocol. So I'm going to show you a scenario where I'm using it and why it was interesting to use it. I'm then going to show you how to implement it yourself if you like to, and how to debug it using either local tool or something in Azure. So I'm currently inside the Foundry portal in front of my agent. This agent is using Blender to build 3D worlds. And it's already exposed in Teams and Microsoft 365 using the Publish button. So if you click on this button, you can then export your hosted agent to those two clients on the Microsoft 365 platform. But by default, we are using a bridge that's going to convert the response protocol, which is a native way to communicate for agents on our platform, to the activity protocol of the M365 platform. But we're doing default choices that could be improved using the activity protocol. So let's see an example, for instance. So let's go inside Teams. I'm going to launch a prompt to my agent running in Foundry. So it's going to wake up my the micro VM associated to my session in Teams, and you see that I've got custom message there. So custom message, if I wasn't using the activity protocol, it would do something generic like, please wait while I'm processing your request. In my case, I can send back real-time event about what I'm doing in my agent. Of course, this agent could take time because rendering 3D, building 3D takes time. You need to live generate the Python code to execute that in Blender, do screenshot, do rendering. So sometimes it could go over the timeout that you've got for a session in Teams or Copilot. So you see that I switched to a message saying like, okay, it takes time. The second message that you've seen is using the proactive messages. This is something I couldn't have done using, once again, the default export button. The activity protocol let me do that, meaning that this time I can send message when they're ready on the agent side to the Teams client directly. So this is also working inside Copilot. So if I'm going inside Copilot and looks for my agent, you see that I've got my Blender agent. I've got starting conversation starter there. So let's pick one and see the behavior. So while the other agent is working inside Teams, let's do something else in Microsoft 365 Copilot. So you will see you have the very same experience, meaning that I will be able to customize the message sent back from my middleware using the activity protocol. So this is the first time, I'm discussing through this session with the agent. So it's based on micro VM, meaning that I've got full isolation. So the Blender, scene of my Copilot 365 won't modify the Blender scene of my Teams session, of course. And once again, as I won't be able to do everything in less than 45 seconds, I should probably switch to the experience where I would say like, okay, it takes time, so I will ping you back when everything is ready. The same way we are using coding agent today. You launch a prompt and do something else most of the time. Okay, so let's go back to Teams. So it should have finished its work. So we have a beautiful output you see in a couple of seconds. By the way, I wanted to show you that in Foundry, this agent is currently using one of the latest models we have available, which is GPT 5.6 Tera. It's an amazing model to play with Blender, so give it a try. And if we go back in Teams, so you see that now I can potentially iterate on that. So something else that you can do is, for instance, find model for an animal. If I'm doing that, I'm going to ping a service that contains many 3D models, and those models are displayed using thumbnails. Once again, if I wasn't using the activity protocol, I would have probably like the URL of the model stream back to the client. In my case, I'm going to use something specific for Teams and Copilot, which is adaptive cards. Adaptive card is something, native in the activity protocol world. So I'm going to do a custom UX to be rendered from my hosted agent to Teams. And you see that now I have a list of cool images to play with. I can click on one of them and they will be automatically injected into my Blender scene, or I can do more stuff like custom stuff, like take the red one, so it should understand which one I'm talking about. Make it as big as the house, put it in front of the house, and do a new rendering. So once again, because I've got my different isolation of scene using the micro VM storage, I can reload the scene, and inspect it and understand what the user is talking about. So you can have this memory and context, maintained by the platform. So now let's go back to M365, do a refresh to see what was going on. So you see that he was able to build the world, to be able to build also the full nice rendering. I can iterate, the same way I can also do adaptive card, but something else that is really interesting also to consider in this scenario, you can see how far I can go in a couple of seconds using my agent hosted in Foundry from, Copilot or Teams. But let's imagine now as a Lambda user, I'm not a 3D modeler expert. It's very difficult for me to use Blender, even if I love 3D. Now maybe it's time to do a handover to a 3D artist. This is where the human in the loop comes into the game. So I can say like, okay, I was able to do a lot of cool stuff, but now let me download the Blender scene. Okay, this time I'm coding another tool on the Foundry side that's going to ask to Blender to inspect the scene and then to download it as a Blender file. So I'm going to generate this file and put that on an Azure Blob storage to have a public URL to be able to download. Then I'm clicking on it and then it will download it. And I can then open directly in Blender what the agent has been working on. So you see now I can potentially modify, and I'm really bad in Blender, so I won't be able to do that. But let's imagine now you have a 3D artist working on it, doing some customization. It can give you back the file, and you could even, give that back to the agent and continue the iteration. So it's really like kind of a full end-to-end experience you may have with agent and 3D. So if we go back inside Teams, you see that he was able to do exactly what I was asking for, to take the model and put that in front of the house and do a new rendering. Okay, now let's see how you should do that yourself now. So if we go inside Foundry, you will see that I've got many protocols enabled for now. So I've got the response one, which is the default one to do anything related to text. Invocation one is the voice. My agent can be also called from my custom web chat client using my voice, so I can discuss with my agent to do also 3D creation. And the last one is the one that we've been using so far, that is the activity one, to be natively integrated into Teams and Copilot. So you will see that you have also endpoints, to be used from there. And what you need to know is when you click on the button there, it will create for you a bot that is available in Azure, so we will see that for the debugging part. But regarding the code, what you need to do is to first, change the agent.yaml definition file. So this is a file defining, it's a manifest in a way of your agent. And you see that this is where the protocol are defined. So what you need to do is to inject the activity protocol there. Okay, and then in your code, of course, you need to now have a new way to measure this type of message coming to your hosted agents. So this is the role of this specific file that I've been creating. If I'm looking inside this file that is dedicated to Teams and Copilot, for instance, I have events that are specific to those platforms, like members added. When you're joining a conversation as a user in Teams, you can have a welcome message. So this is a welcome text message that we can see there. And then you will see that, okay, I'm there to help you to do stuff with Blender. And you can even have like a kind of a suggested prompt that is there. So this message will be sent automatically to the user. But also what I can do in my code, this is what we've seen so far, is to create adaptive card. So those adaptive card is simply specific JSON that you're going to produce and inject that into the activity protocol message using the send activity method. And you see that this is the way you're going to define columns. You say that it's type image with the URL, the size, and the alignment and all that. This is specific to Teams. And we're going to see how to now debug that, because this is maybe brand new for you. So the first thing that you need to understand, as I was telling you, is that when you click, publish there, it's going to create a bot for you. The bot will be created inside your Azure subscription, where your Foundry project also is in the same resource group. So this is the bot that has been created. And what you need to know is that you can test inside a simple web chat client that your bot at least is going to answer. Like if it works there, I should have a welcome message. If I've got a welcome message, this is a great news. It means that my hosted agent was able to be pinged and give me back the default message. And you see, it works. So this is the message we've just seen in VS Code in the Python code. So now I can ask create 3 cubes of different color. And we will have the same experience that we've seen so far, custom messages. And then I'm going to send message every time I'm calling a specific tool, like creating the scene, executing Blender code, doing screenshots. Okay, now the last way to be able to debug is to use your local dev machine. Of course, you need to have the Foundry model being hosted by Foundry. So this is the only part, like now in this part of the demo, that run inside the Microsoft platform. But now I'm going to use my local Docker, capability to be able to launch it. So this script, this is what it's doing. So I'm going to use Docker run, expose the right ports. I've got 2 ports exposed, the default one and one for voice. Wait for it to start. And once it's ready to answer to my question, I'm going to launch the Microsoft 365 Agent Toolkit Playground tool. So this Playground tool can be installed using NPM or Winget on Windows or whatever. And then it's going to simulate Teams on my machine. So you see that I was able to have the same message there. And now I can give it a try. And this is very convenient because now all the Docker image is running on my machine, calling Blender on my machine, using the remote model, but I'm simulating Teams on my machine, meaning now I can really test those specifics of Teams like adaptive card and see how it works inside this simulator to be sure that, I'm not missing something before deploying to production. So this is a way I've been using in my case to create the adaptive card features, debug it using the Playground tool before deploying that to production. And you see that it's working exactly the same we've seen so far. So this is everything I wanted to show you, is really how to be able to control the output, of a hosted agent for Teams and Copilot using the activity protocol. I think we were able to do fun stuff, like you can see, like those beautiful words. Adaptive card, we can control, the output using proactive messages. Feel free to share what you think about that. Like, it's still in public preview. If you like to implement that into your own agent, we have a list of cool samples that are using Copilot SDK. But in my case, my sample is using Agent Framework. I will share the link in the description below to let you find my own agent and those samples to be able to play with. Provide your feedback. Tell me what you think about my scenario, if it is cool or not, and see you soon. Thank you.